Welcome to Visuality Systems, the SMB protocol experts. In today's tutorial, we'll be discussing key SMB protocol security measures that will help you safeguard your data and your network. As part of Microsoft's Secure Future initiative, launched in 2023 to address the growing scale and complexity of cyber attacks, Windows 11 version 2.4H2 and Windows Server 2025 now include important SMB features that make your data, your users, and your organization safer. Most of these features are enabled by default, ensuring that your network is secure from the start. The security measures introduced by Microsoft, all supported by Visuality Systems' SMB protocol software libraries, include SMB Signing required by default, SMB NTLM Blocking. Insecure guest authentication is now off by default in Windows Pro editions. SMB Dialect Management, SMB Client Encryption Mandate, deprecation and disabling of remote mail slots. SMB over QUIC is now supported not only in the Azure edition as it was in Windows Server 2022, but also in the Data Center and Standard edition starting from Windows Server 2025. SMB over QUIC Client Access Control, support for SMB on alternative ports. Let's begin with the foundation of SMB Security Signing, a simple yet powerful way to ensure the authenticity and integrity of every packet exchanged. SMB Signing adds a digital signature to SMB messages. This signature, located in the SMB header, is a hash generated by a cipher suite using the session key. It confirms the identity of both the sender and the receiver. If the message is tampered with during transmission, the hash will not match, indicating a security issue. SMB Signing provides two essential benefits. First, it ensures the integrity of your data by verifying that it hasn't been altered. Second, it authenticates both the server and the client, preventing adversary-in-the-middle attacks. SMB Signing has been around since Windows NT. Initially, SMB 1 supported signing, but it was not enforced. Over time, Microsoft has improved the signing algorithms, evolving from MD5 in SMB 1 to HMAC SHA 256 in SMB 2 and AES CMAC in SMB 3. Most recently, AES 128 GMAC was added in Windows 11 and Windows Server 2022, offering even stronger security. Before these updates, SMB Signing was only required by default for Sysful, Netlogon, or if enforced by an Active Directory domain controller. Devices using guest access had signing disabled by default. As a result, only knowledgeable administrators were able to enable SMB Signing across their networks. Now, with the new changes, SMB Signing is required by default. To disable it, you must opt out intentionally. If you're using guest access or connecting to devices that don't support SMB Signing, you'll likely encounter error messages, as the system now prioritizes secure connections. To check the current SMB Signing status, use the following PowerShell command. Get SMB Client Configuration, pipe, FL, require security signature. In our case, we get a false, which means that, on this client, SMB Signing is disabled. In order to enable SMB Signing, run the following command. Set SMB Client Configuration, require security signature, $true. The system will prompt for confirmation. Once approved, SMB Signing will be enforced for this client. In this example, we used SMB Client Configuration for outbound signing. SMB Server Configuration is the corresponding command for inbound signing. Here are some important do's and don'ts when working with SMB Signing. Use Kerberos instead of NTLM version 2 for secure authentication. Assign alternate computer names using the NextDome tool. Don't disable SMB Signing as a workaround. Avoid signing in with guest accounts. Never connect to shares using IP addresses. Refrain from using CNAME DNS records for SMB connections. Building on authentication integrity, let's now look at how SMB is moving forward by blocking NTLM. This feature reduces exposure to attacks by limiting the use of outdated NTLM authentication and instead relying on the more secure Kerberos protocol. NTLM blocking aims to enhance security by reducing the dependency on NTLM, an authentication protocol that uses outdated algorithms like HMAC MD5 and MD4 that are vulnerable to unwanted attacks. SMB clients now block NTLM for outbound connections, preventing NTLM requests from being diverted to potentially malicious servers. This shift aligns with the NTLM disable policy introduced in Active Directory since Windows Server 2008. In domain environments, Kerberos authentication takes over, ensuring stronger protection. Once NTLM is blocked, the most secure and efficient alternative is Kerberos. Unlike NTLM, which relies on challenge response mechanisms, Kerberos provides mutual authentication, ensuring that both the client and the server trust each other before any data exchange. Kerberos operates with a ticket-based system, where encrypted tickets are issued to users or services. This eliminates the need to repeatedly transmit passwords across the network, significantly reducing the risk of credential theft. Additionally, Kerberos tickets are time-limited, meaning attackers have a smaller window of opportunity to exploit a session. With strong encryption algorithms like AES, Kerberos offers superior protection compared to NTLM. It's also tightly integrated with Active Directory, making it the authentication protocol of choice for Windows domains. By switching to Kerberos, you ensure a more secure and streamlined authentication process. Before NTLM blocking, Windows used the SP-NAGO protocol to negotiate between different authentication mechanisms, including Kerberos and NTLM, depending on the server and client setup. In some cases, this negotiation could result in a downgrade from Kerberos to NTLM, which weakened the overall security. However, for Active Directory domain-joined computers, Kerberos was still the default method for authentication and connectivity, while an option to disable NTLM was added with Windows Server 2008. With NTLM blocking, organizations are now required to shift their authentication to the more secure Kerberos protocol, which uses a ticket system and stronger cryptography to verify identities, even on the client side. However, administrators can still allow exceptions for specific servers that don't support Kerberos. It's important to note that NTLM blocking doesn't impact local NTLM usage, like mapping a drive locally with a local account. Blocking NTLM will prevent connections, not only inbound but now also outbound, in several cases. If the client uses an IP address, if the Kerberos CIF service principal name is missing an Active Directory for the SMB server, or if local user account credentials are used for the SMB server. In cases where NTLM blocking triggers an error, troubleshooting steps can help identify the source of the issue. You might temporarily disable NTLM blocking to check for other network issues, like DNS name resolution. If you've connected using an IP address, try switching to a fully qualified domain name. You can verify that the SMB server has the necessary host service principal name registered using the set SBN command. If still unable to connect, use a network capture tool, like Wireshark for example, to examine the client and server messages for DNS, SMB2, and Kerberos. To enable NTLM blocking across your SMB client configurations, you can use this PowerShell command. Simply run set SMB client configuration block NTLM true, which enforces NTLM blocking for outbound connections from the client. Once confirmed, NTLM will be disabled, paving the way to stronger authentication methods. Another option for blocking NTLM authentication on a per-connection basis is to use the new SMB mapping command. This command applies NTLM blocking when creating a new SMB mapping to a specific server share, adding flexibility for enforcing NTLM restrictions based on individual connections. To conclude, let's compare NTLM and Kerberos. NTLM relies on challenge response authentication, while Kerberos uses a ticket-based system. NTLM's encryption is outdated, using MD4 or MD5, whereas Kerberos employs AES, a stronger modern encryption standard. NTLM only authenticates the client, leaving it more vulnerable to certain attacks, while Kerberos provides mutual authentication, protecting both client and server. While NTLM can still serve legacy systems as a fallback, Kerberos is the preferred default for Active Directory environments and modern deployments, offering single sign-on and a higher security profile. This is why Microsoft's security initiatives include disabling NTLM in favor of Kerberos, especially in Active Directory and SMB protocol environments. While NTLM is being phased out, another long-standing vulnerability is also being addressed: insecure guest logons. Guest connections are intrinsically vulnerable because they don't require passwords and don't support signing and encryption. Under these insecure conditions, a malicious agent can do the following: trick clients into connecting to a fake server, intercept sensitive data, gain unauthorized access, and perform man-in-the-middle attacks. This is why Microsoft had already disabled inbound guest access to SMB servers by default since Windows 2000. And, as we will see, is applying this security measure also to SMB clients, which means outbound connections. Before this change, Windows 11 Pro allowed SMB clients to connect as guests or to fall back to a guest connection with an SMB server when necessary. This often came into play with remote storage devices or network-attached storage, where guest access was sometimes the default for convenience. However, this fallback also exposed devices to potential unauthorized access. After this change, Windows 11 Pro clients no longer allow guest connections or fallback guest logins to an SMB server. Now, any attempt to make an outbound guest connection is rejected, preventing insecure guest logons. This shift aligns client and server behavior to eliminate this security vulnerability across the board. When outbound guest access is disabled but the server still expects it, an error will occur. This incompatibility can lead to blocked connections, but it's a necessary security measure to prevent unauthorized agents from reading or copying shared data. Guest access does not support SMB signing or encryption session keys, which are critical for secure communication. Anyway, do not enable vulnerable SMB1 as a workaround. SMB1 should be disabled by default in all Windows versions. As a last resort, you can enable insecure guest logon, but this severely compromises security. Guest access settings can be controlled via PowerShell. The following command provides the necessary control of guest behavior. Set SMB client configuration enable insecure guest logons $true force. In order to use guest logons, both SMB signing and SMB encryption must be disabled. However, doing so can compromise the client's security. In this example, we used SMB client configuration for outbound connections. SMB server configuration is the corresponding command for inbound connections. Here are some best practices and common pitfalls when managing guest authentication. Disable guest access on remote devices wherever possible, or consider replacing devices that rely on insecure access. Also, enable auditing for any outbound guest logons supported on Windows 11 or Windows Server 2025 to monitor and detect unauthorized access attempts. Avoid enabling guest access altogether and do not disable SMB signing or encryption. Similarly, avoid enabling SMB1 as it poses significant security vulnerabilities that outweigh any compatibility conveniences. Controlling who can connect is key, but so is controlling how they connect. That's where SMB Dialect Management comes in. Dialect management in SMB is all about managing the protocol version, or dialect, that the client and server use to communicate. When a session is established, the SMB client and server negotiate to agree on a common dialect. If one side supports a higher dialect, it must adjust to the lower version supported by the other. This ensures backward compatibility, but also means that dialect management plays a crucial role in security and functionality. Previously, SMB automatically handled dialect matching between client and server. The server and client would negotiate the highest mutually supported version, ranging from SMB 202 up to 311. However, control was limited. While SMB client dialects could be managed starting with Windows 10, server dialects were still auto-negotiated without admin intervention. With the recent updates in Windows 11 and Windows Server 2025, administrators can now set minimum and maximum SMB dialects on both clients and servers. This allows IT teams to specify which SMB versions are acceptable, blocking outdated SMB versions from connecting. You can mandate specific SMB 2N3 protocol versions, creating a more secure controlled environment by independently setting minimum and maximum dialects based on organizational needs. Administrators can manage dialect settings through PowerShell, giving precise control over the SMB dialects that clients and servers are allowed to negotiate from SMB 202 and higher. By using commands like set SMB server configuration, the minimum and maximum dialects can be set to restrict communication to supported versions. For example, setting the minimum dialect to SMB 311 and the maximum to none restricts connections to SMB 311 on the server side, increasing security by blocking outdated versions. In this example, we used SMB server configuration for inbound connections. SMB client configuration is the corresponding command for outbound connections. In an SMB connection, the client and server must negotiate and settle on a common dialect to communicate. Let's take an example scenario where the client supports SMB 311, but the server only supports SMB 302. This mismatch requires the client to adjust its dialect to align with the server's capabilities, ensuring both ends are compatible. In this situation, the client must compromise by downgrading its protocol to match the highest version supported by the server, SMB 302. Although the client can support newer features in SMB 311, it needs to revert to SMB 302 to ensure connectivity and compatibility with the server. Once the client downgrades to SMB 302, a connection can successfully be established, provided both the client and server support this common version. This compromise enables communication while honoring the security and compatibility limits enforced by dialect settings. Beyond negotiation, ensuring confidentiality in transit is critical. Let's explore client encryption and how it's now being enforced. Encryption is the process of transforming data into an unreadable format, accessible only with a decryption key, ensuring its confidentiality during transmission. This feature was first introduced as an optional capability with SMB 3 on Windows 8 and Windows Server 2012. Administrators now have the ability to enforce SMB 3 with encryption for both inbound and outbound connections, providing robust security for clients, shares, file servers, drives, and even UNC hardening. Let's take a look at the evolution of SMB encryption across various Windows versions and how it has strengthened over time. In 2012, with Windows 8 and Windows Server 2012, SMB 3 introduced encryption for the first time, using AES 128 CCM as an optional feature. A year later, Windows 8.1 and Server 2012 R2 built on this foundation with enhanced encryption support, continuing with AES 128 CCM. In 2015, Windows 10 and Server 2016 introduced SMB 311, bringing more robust encryption algorithms, including AES 128 GCM alongside CCM. By 2021, Windows 11 and Server 2022 added even stronger encryption capabilities, introducing AES 256 GCM alongside CCM and setting more secure defaults for SMB connections. Finally, Windows 11 and Server 2025 introduced support for mandatory client encryption, ensuring the highest level of security with all previously available algorithms. Each step in this timeline represents Microsoft's commitment to enhancing data protection and aligning with the latest security standards. Before these changes, SMB encryption had to be configured manually. Administrators could enable encryption on a per-share basis, apply it across the entire file server, or enforce it selectively when mapping drives. Additionally, UNC hardening was used to strengthen access to specific network paths, ensuring a higher level of protection for sensitive resources. However, these configurations required careful planning and were not always consistently applied across environments. With the change in place, the SMB client is configured to always enforce encryption, ensuring secure communication regardless of server settings, share configurations, or map drive requirements. Administrators now have the ability to mandate encryption for Windows SMB clients, blocking outbound connections to any server that doesn't support it, reinforcing security across the network. PowerShell commands provide a straightforward way to manage client encryption settings. The command get SMB client configuration, pipe to format list, require encryption, allows administrators to check if encryption is currently required on the client. In this example, it shows false, indicating that encryption is not enforced. To enable encryption, use set SMB client configuration - require encryption true. This will prompt for confirmation before applying the change, ensuring administrators can review the action. While SMB client configuration controls outbound encryption settings for SMB clients, the corresponding SMB server configuration command handles inbound encryption settings on SMB servers. Together, these tools provide comprehensive control over encryption policies in your network. Let's compare SMB signing and SMB encryption. SMB signing delivers better performance since it avoids the overhead of encryption processes, while SMB encryption introduces higher performance costs due to its data protection mechanisms. Both methods provide tamper protection, but only SMB encryption guards against snooping by encrypting the data. Signing offers broader compatibility with older systems, while encryption, though more secure, may face compatibility challenges in certain environments. SMB signing can be a good choice when performance and basic security are priorities, while encryption is ideal for scenarios where both tamper and snooping protections are essential. It's important to note that when encryption is enabled, signing is automatically disabled because encryption already includes tamper protection. For maximum security, consider the trade-offs between these two features to determine the best fit for your use case. Securing active communication is essential, but reducing attack surfaces also matters. Here's why remote mail slots are being deprecated. The remote mail slot protocol, introduced in MS-DOS and used in older Windows versions, is an obsolete method of inter-process communication, which is IPC. Unreliable and unsafe due to its lack of authentication and encryption, it was once a key component of SMB for tasks like simple messaging and network discovery. However, as newer SMB versions evolved, the dependency on remote mail slots was eliminated, leading to their deprecation. Starting with Windows 11 and Server 2025, this vulnerable protocol is disabled by default to protect against attacks like spoofing and interception. As a significant security enhancement, Microsoft disabled SMB by default in Windows 10. This was a crucial step to protect systems from known vulnerabilities associated with this older protocol. However, it's important to note that some users may still have SMB enabled on their systems. This could be due to legacy applications or specific configurations. These users might encounter issues if they rely on applications that utilize remote mail slots, as these applications often depend on SMB for communication. After the change, any attempt to use obsolete systems based on SMB and remote mail slots will result in an error message stating, "The requested operation failed. Remote mail slots have been deprecated." This ensures older, insecure methods are no longer inadvertently used, encouraging a move to more secure alternatives. When encountering issues related to remote mail slots, the first step is to contact your vendor and request an update to their outdated software. However, if you need to temporarily re-enable remote mail slots for legacy compatibility, you can use the PowerShell command shown here. Set SMB client configuration, enable mail slots true. Upon running the command, you'll be prompted to confirm the action, ensuring that the change is intentional. This temporary re-enablement allows for transitional support while working toward a permanent secure solution. In this example, we used SMB client configuration for outbound connections. SMB server configuration is the corresponding command for inbound connections. To ensure a secure and modern SMB environment, follow these best practices. Do reach out to your vendor to update their software, or consider switching to a vendor that provides a secure, up-to-date solution. Don't use SMB or remote mail slots, as they have been deprecated due to serious security risks, including the lack of encryption and authentication. Eliminating outdated protocols helps protect your network from potential attacks. With legacy features fading out, new secure transport options are being introduced. Let's dive into SMB over QUIC, now supported across Windows Server editions. SMB over QUIC is an alternative to the legacy TCP protocol and RDMA, and is designed for secure use of untrusted networks like the Internet. It uses TLS 1.3 for encryption, establishing a secure tunnel over UDP port 443 instead of TCP port 445. Unlike traditional authentication methods that rely on passwords, SMB over QUIC uses certificates to ensure security. This enables all SMB traffic, including authentication, multi-channel, and compression, to pass through edge firewalls, allowing seamless access for mobile and remote users without the need for a VPN. Importantly, the user experience remains unchanged. By default, SMB over QUIC is not enabled, and a client cannot force a file server to use it. Instead, a file server administrator must explicitly opt in to enable SMB over QUIC. Additionally, client access control, covered in a separate video, allows administrators to restrict which clients can, or cannot, connect to SMB over QUIC servers. Before the change, SMB over QUIC in Windows Server 2022 was restricted to Azure Edition machines only. This meant that if you wanted to use SMB over QUIC, your file server had to run the Azure-specific version of Windows Server. The feature wasn't available for standard or data center editions, limiting its accessibility for many organizations outside of Azure. SMB over QUIC is now included in all Windows Server 2025 editions, not only on Azure Edition, like it was in Windows Server 2022, but also on Data Center and Standard editions. Before configuring SMB over QUIC on the server, we need to obtain the certificate thumbprint. This thumbprint uniquely identifies the certificate used for secure communication. Once you have the thumbprint, use the following PowerShell command to map the certificate to your SMB server. New SMB server certificate mapping, name server FQDN, thumbprint certificate thumbprint, store name my. Here, the fully qualified domain name, or FQDN, represents the complete hostname of the server, including the domain and top-level domain. Now that SMB over QUIC is configured, we can connect from a Windows 11 client using the following command. Net use server FQDN transport, QUIC. If the connection is successful, you'll see a confirmation message indicating that a drive has been mapped to the SMB server over QUIC. At this point, the setup is complete, and the client is securely connected using SMB over QUIC. When configuring SMB over QUIC, following best practices ensures a secure and efficient deployment. Let's go over the key recommendations. First, whenever possible, use SMB over QUIC within an Active Directory domain. This provides stronger authentication and management capabilities. Second, keep SMB over QUIC running on its default inbound port, UDP 443, unless a specific configuration requires otherwise. Finally, if your deployment includes domain controllers, they should be read-only to minimize security risks. Do not allow inbound connections over TCP port 445 on your file server. SMB over QUIC eliminates the need for this, reducing attack surface and improving security. Also, avoid using IP addresses in the server's subject alternative name. Doing so forces authentication to fall back to NTLM, which is less secure, even if Kerberos is available through a domain controller or KDC proxy. By following these best practices and avoiding common pitfalls, you can ensure a more secure and resilient SMB over QUIC deployment. QUIC is fast and secure, but who's allowed to connect matters just as much. Let's explore client access control for SMB over QUIC. A feature that restricts which clients can connect to an SMB over QUIC server. Client access control uses allow and block lists to specify which devices are permitted or denied access. This feature is optional and not enabled by default, but when configured, it provides an additional layer of protection without altering the authentication method in use. Before this change, any client that trusted the server's certificate could connect to an SMB over QUIC server. There were no built-in controls to restrict access based on specific devices, relying solely on certificate trust for authentication. After the change, a client needs its own certificate and be on an allow list to complete the QUIC connection before any SMB connection occurs. The client trusts the server via a valid shared root authority key, and the client certificate is added to a trust list managed by the server. You get more protection without changing SMB authentication and user experience. Admins can also completely disable the SMB over QUIC client, allow connection to specific servers, or revoke certificates. Certificates containing multiple subject alternative names are supported. To configure SMB over QUIC client access control, we first need to retrieve the certificate thumbprints of the client certificates. This can be done using the getChildItem command in PowerShell, specifying the local machine's certificate store. The output lists the available certificates, displaying their thumbprints and subjects. These thumbprints will be used to define which clients are allowed or blocked from accessing the SMB over QUIC server. Next, we store the specific client certificate in a variable by filtering the list of certificates based on the subject name. This command retrieves the certificate from the local machine store where the subject matches the specified name. The thumbprint of the selected certificate will be used to configure client access control for SMB over QUIC. Now we retrieve the SHA-256 hash of the client certificate, which will be used for access control. Next, we create an SMB client certificate mapping by associating the certificate's thumbprint with a specific namespace. To grant access, we use the Grant SMB Client Access to Server command. This can be done in two ways. 1. By specifying the SHA-256 hash of the certificate. 2. By using the certificate issuer's subject name to allow all certificates issued by the same authority. These commands ensure that only approved clients can connect to the SMB over QUIC server. To connect to an SMB over QUIC server, we use the new SMB mapping command, specifying the remote server's DNS name and share. Next, the Set SMB Client Configuration command disables SMB over QUIC by setting Enable SMB QUIC to false. This step is optional, but can be useful for testing or enforcing a specific transport method. When prompted, confirm the change by selecting Y for Yes. When implementing SMB over QUIC client access control, follow these best practices to enhance security. Do use certificate-based authentication to strictly control which clients can connect to the server. Test your access control settings in a non-production environment before rolling them out. Don't rely only on firewall rules for security. Certificate-based access control is essential for end-to-end protection. Do not overlook certificate renewal. Expired certificates can lead to access disruptions or security risks. Finally, with all these layers in place, flexibility and control at the network level are essential. Here's how SMB now supports alternative ports. In networking, service names and port numbers are used to differentiate between various services running over transport protocols. For SMB, the default ports assigned by IANA and IETF are TCP 445, QUIC 443, and RDMA 5445. However, alternative ports can be configured, allowing any number between 0 and 65,536 to be used, depending on your network setup and security requirements. SMB Server in Windows has required inbound connections using the IANA registered port TCP 445 for decades, and the SMB TCP client has only supported connecting outbound to that TCP port. The newer SMB over QUIC protocol requires the QUIC-mandated UDP 443, both for server and client. Until now, these were hard-coded and unalterable. After the change, SMB servers can now accept inbound connections on any configured port, not just the default ones. However, to maintain control and security, you can block alternative ports on the client side, ensuring that it only connects to specific, authorized servers. You can configure an SMB client to connect using an alternative port by specifying it in the new SMB mapping PowerShell command. Whether you're using TCP, QUIC, or RDMA, simply provide the desired port number within the valid range of 0 to 65536. This allows for greater flexibility in managing SMB connections while maintaining control over network traffic. To view all configured alternative ports on an SMB server, use the Get SMB Server Alternative Port PowerShell command. This command lists the available ports, their associated transport types, such as TCP or QUIC, and whether they are enabled for SMB connections. Here, we see that port 443 is assigned to QUIC with a default status, while port 445 is set for TCP and explicitly enabled. To manage alternative ports for SMB over QUIC, PowerShell provides several commands. To add a new alternative port, use new SMB Server Alternative Port, specifying the transport type as QUIC and the new port number. To remove an existing alternative port, use Remove SMB Server Alternative Port, followed by the transport type and the port number you want to delete. To modify an existing port, use Set SMB Server Alternative Port, providing both the old and new port numbers. These commands allow fine-tuned control over SMB traffic, ensuring compatibility with custom network configurations. When configuring SMB alternative ports, keep these best practices in mind. Do assign unique ports for different transport types to prevent conflicts and ensure smooth operation. Do verify connectivity and functionality after making any port changes to avoid unexpected disruptions. Don't rely on default settings without considering security requirements. Customizing ports can enhance protection. Don't assume everything will work seamlessly. Always test your configuration before deploying it in a production environment. Following these guidelines will help maintain a secure and reliable SMB setup. Thank you for watching. Want to know more? Explore the other videos in this tutorial series, visit our website, or reach out for more insights. Visuality Systems, the SMB protocol experts.